So use Simpson's rule. Now, when they say Simpson's rule without specifying either third or 3/8, know that they are referring to a third rule. But if they specify, you will and okay. Third rule to evaluate integral from 0 to 1. Just use the same example. When n equals to 4 and 2, n equals to 8. So solution, we write that Simpson's rule says that integral from a to b of f of x is given by h over 3 into f naught plus fn plus 2 plus 4 naught 2 plus 4 into f1 plus f3 plus f5 plus 2 into f2 plus f4 plus f6. So when n equals to 4, we mean that 1 minus 0 over 4 becomes the h. So h will be 1 over 4. So therefore, we have x, and then we have f, 0, 1 over 4, 2 over 4, and then we have 3 over 4, and then 4 over 4, which is the same as 1. This was 0, and then this was 1 over 256. This was 1 over 16. This was 81 over 256. And then this is 1. So with our formula, we'll have integral from 0 to 1 of x power 4 dx. The approximately equals to, so we have now h, which is 1 over 4, so it'll be 1 over 12 into 0 plus 1 plus 2. So remember, this is the f naught, f1, f2, f3, f4. So the formula will be f naught plus f4. Those are the extremes. Plus 4 into f1 plus f3. And then to the only event that we take now will be f2. So plus twice 1 over 256 plus 81 plus 1 over 81 over 256, and then plus, this is 4. So plus 1 over plus, so this is 4, and then 2 into 1 over 16. When you work out this one, the answer will be 0.2005 20833. Then the percentage error in this calculation will be given by the true value is 0.2 minus 0.200520.833 over 0.2, which is the true value, times 100%. And this one is approximately 0.2604166666%. So which is roughly 0.26%. Now, when you compare this error with what we did in the case of trapezoidal rule, you see that this one is much lesser. So comparing this with the answer for trapezoidal rule, we see that this is smaller, which implies a better approximation. So in general, Simpsons third rule is a better approximation method compared to trapezoidal rule. Now the second case, we had n equals to 8. So n equals to 8 means that our h will be 1 minus 0 over 8, which is 1 over 8. So this is what we have, 8 over 8, which is 1. So from our previous example, we see that this will be 0, 1 over 4096, 1 over 256, 81 over 4096, 1 over 16, 625 over 4096, and then 81 over 256, and then 241 over 4096, and then lastly 1. So here you can actually label these ordinates. This as your F0, F1, F2, F3, F4, F5, F6, F7, F8. And then you remember the integral from 0 to 1 of x power 4 dx will now be given by, so h over 3 into f0 plus f8, the extreme ordinates, 4 into f1 plus f3 plus f5 plus f7, and then plus 2 even ordinates, we have f2, f4, f6. So replacing in now, we have h is 1 over 8, so will be 1 over 24 into 0 plus 2401 over 4096 plus 4 into 1 over 4096 plus 81 over 40, 96, plus 625 over 40, 96, plus 2401 over 40, 96, plus twice 1 over 256 plus 1 over 16 plus 81 over 256. Now work out this one and get the answer. And also, the answer you get, calculate the truncation error, which will be assuming that this answer box, that's under this box here, will be 0.2 minus that box. And then go ahead and then calculate the percentage error. It will be given by 0.2 minus the answer you have there over 0.2 times 100%. You should see that this percentage error must be smaller than this percentage error when you use the same value as n equals to 8 in the trapezoidal case. So next example, evaluate. So try to do as many examples as possible to test yourself on speed and accuracy. Evaluate this integral 0 to 1 of 1 over 1 plus x, the x correct to 3 decimal places. So we'll take various methods and various types of h. So I want us now to use h 0.5, and then we use both trapezoidal rule and Simpson's third rule. So we'll have now, remember for this case, when you have such an integral, you just relate it to integral f of x dx. So therefore, it is not hard to see that the function here is 1 over 1 plus x. So when you use h as 0.5, then it means that then this is what you'll have. So this is like a half. Like we have x 0, a half, then 2 over 2, which is just 1. So this is f. So when x is 0, just put here, this is the function. 0, 1 over 1 plus 0 is just 1. 0.5, put it here, should get 0.6667. 1, you should get 0.5, 0, 0, 0. So therefore now you say by trapezoidal rule, we'll have I will be, so h, remember h is 0.5. So 0.5 divided by 2 will be same as 5 over 20, which is same as 1 over 4. So we'll have 1 over 4 into 1.0000 plus 2 into 0.6667 and then plus 0.5000. So the answer becomes 0.70835. And then Simpson's rule. So remember, I said when they say Simpson's rule without specifying, you know that they are referring to the third rule. So Simpson's rule will have I will be given by h over 3 into f naught plus f. So remember, you can label this. Label this one as, this is f naught, f1, f2. So it'll be f naught plus f2, and then plus 4 f1. So this will be given by 1 over 6 into 1.0000 plus 0.5000 plus 4 into 0.6667. When you work it out, the answer will be 0.6945. And then let's take h as 0.25. So taking h as 0.25, that simply means 1 over 4. Then we'll have these values x and f. So 0 will have 1.000, and then 0.25 will have 0.8000, 0.50 will have 0.6667, 0.75, 0.5714, and then 1 will have 0.5000. So a trapezoidal rule will have the integral be given by 1 over 8 into 1.0000 plus 0.5000 plus twice 0.8000 plus 0.6667 plus 0.5714. So this, when you work it out, you get 0.6970. And then if we use B. Simpson's method, or Simpson's rule, we'll have the integral will be given by 1 over 12 into 1 plus 0.5 plus 4 into 0.8 plus 0.5714 plus 2, 0.6667. So when you work out this one, you get 0.6932. Now, assuming now we take now the last case, case 3, assuming that now we take our h to be 0.125. So this is the table that we'll have. So we'll have 0.00, 0.125, 0.250, 0.375, 0.500, 0.625, 0.750, 0.875, and then 1.000. So here we have 1.0000. Here we have 0.8889, 0.8000, 0.7273, 0.6667, 0.6154, 0.5714, and then 0.5333, and then when x is 1, so we have 0.5000. You can label these ordinates as this is our f0, f1, f2, f3, f4, f5, f6, f7, f8. So by trapezium rule, we'll have the integral 0 to 1 will be h over 2 into f0 plus f8 plus 2 into f1 plus f2 plus f3 plus f4 plus f5 plus f6 plus f7. So which will be given by h, for this case is 0.125. So dividing by 2, we get 1 over 16 into 1.000 plus twice into 0.8889 plus 0.8000 plus 0.7273 plus 0.6667 plus 0.6154 plus 0.5714 plus 0.5333. So when you work out, you'll get 0.6941. Now B, Simpson's rule, will have integral from 0 to 1 of 1 given by h over 3 into f0 plus f8 plus 4 into f1 plus f3 plus f5 plus f7, then plus 2 into f2 plus f4 plus f6. So let's substitute in the values. So the h, our h divided by 3 will give us 1 over 24 into 1 plus 0.5 plus 4 into 0.8889 plus 0.7273 plus 0.6154 plus 0.5333 plus 2 into 0.8000 plus 0.6667 plus 0.5714. So when you add all this, you get 0.6932. So to 3 decimal places, we have 0.693. So because now the question wanted us to express our final values correct to 3 decimal places. So at each point, then we just express each number to 3 decimal places. So for this, For 3 decimal places, here it will be 0.694, and then so here will be 0.708, and then here will be 0.695 to 3 decimal places, and then at this other point we'll have 0. 0.697, and then lastly, so we have that one. So at each point just now, you round off your answer to nearest 3 decimal places as required. So 0.693. So this is the answer that you need to put in. So that is how work out. So get another example. We can actually get more examples to work out and see how you will need to work out. So the next lecture will give now the last method of integration called the Romberg integration. Have a good day.